We're now going to walk through a particle motion example where we're given an acceleration and need to use integration to find velocity and distance traveled. We are told that the acceleration function in meters per second squared and the initial velocity are given for a particle moving along the line. Here is our acceleration. It's equal to 2t plus 3, and we're told that the initial velocity, v of 0, is equal to minus 4. We want to find the velocity at time t and the distance traveled during the given time interval, and our interval is where t is between 0 and 3. Just to make things easier, over here on the right, I've written down the formulas that relate position, velocity, and acceleration. When you're given position, you can find velocity and acceleration by differentiation. And then when you're given acceleration, you can find velocity and distance by integration. And that's what we're going to do in this problem. We want to start with part A, finding the velocity at time t. So let's just write down, we're going to find v of t. V of t is the integral of our acceleration function, a of t. Let's now plug in what that is. We are integrating 2t plus 3 dt. This gives us t squared plus 3t, and then we can't forget to add on our arbitrary constant. We can find what this arbitrary constant is by using our initial condition, v of 0 is equal to minus 4. So let's let t be equal to 0. So we have v of 0 is 0 plus c, and that's minus 4. So we know that c is equal to minus 4. That tells us then that v of t is equal to t squared plus 3t minus 4. Now let's look at part B. We want to find the distance traveled during the given time interval. Our distance traveled is typically noted by s, so the distance traveled is going to be s at 3 minus s at 0. That's just the distance at the end of the time interval minus the distance at the beginning of the time interval. The fundamental theorem of calculus tells us that s at 3 minus s at 0 is the integral from 0 to 3 of s prime of t dt. I'm going to put a little star here because I think that's the hardest part of the problem. Once you know that, everything else is not as hard. The next thing we have to do is we have to realize that the derivative of position is our velocity. So s prime of t is v of t. And now we can just substitute in the v that we found in part A. So we're going to integrate from 0 to 3 of t squared plus 3t minus 4 dt. Let's see what this gives us. This is t cubed divided by 3 plus 3t squared divided by 2 minus 4t, and we're evaluating this from 0 to 3. This gives us 3 cubed divided by 3 plus 3 times 3 squared divided by 2 minus 4 times 3. And then it's always nice when our lower limit is 0 because we just subtract off 0. 3 cubed divided by 3 is 27 over 3, which is just 9. And then we have 3 times 3 squared is 27 divided by 2 minus 12. This gives us minus 3 plus 27 divided by 2. We'll get a common denominator of 2, and that's minus 6 plus 27. So this gives us an answer of 21 divided by 2, and we need to put units with that. If we go back up to the top, we were told that our acceleration is meters per second squared. So that means that our distance is in terms of meters. So our distance traveled is 21 divided by 2 meters.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.